And we're gonna start. All right, the 10 minutes of chit chat. We weren't gone through them. So we're gonna do this pattern from Humayun's tomb. It's a 12-fold, it's 6-fold inside a 12-fold. And we see the relatedness to the 12 in that the 6 is located inside of a square. Very, very 12-foldness. But the way that it sort of works is, yeah, once you sort of bounce it off, well, this one actually is a tiling by rotation, which is very interesting. As you can see, the star is rotated by, I think it would be half, what would it be, 90 degrees? So it's like a square just being rotated on its side. It's like this side now becomes this side, sort of, yeah. And so if we can know how to construct one, we know how to construct the other. It can get difficult to construct one of these. So we're gonna look at some simple concepts first, but yeah, so we're gonna need a square. So I have here this letter size paper, and I'm gonna cut it into a square, of course. Now, just a second. What was open? So one of the things I think is important for this design is that we can sort of keep count of how many stars we're going to do. And also what is important is that we can, there is sort of like this preamble to this design, which is to be able to divide an angle into thirds. So we're going to go over that. And that will help us a lot. So I have my excess here. If you have an A4 paper, I think this excess should be bigger than mine. Alrighty. So just this little, I'm going to use this excess just to show you one concept which we are going to be sort of using, the idea of connecting points on by fold. So if I were to tell you that I have these 2 points, could be any 2 points on my piece of paper, and then I wanted to join them, one thing that you could do simply is to take your piece of paper and then just sort of squeeze between these 2 points in a way that you sort of can connect them like so, right? So this is going to be useful because there is this nested star. So this idea of just connecting lines by folds is also very useful. And further, well, if I wanted to sort of build upon this in a way, I can imagine that there's going to be sort of like a third point over here, let's say, not exactly at the edge. So I could use the sort of squeeze method as a way to sort of draft my lines. It's not optimal, it's not the best. As you can see, I'm stopping at the points. That would be my idea for this, to be able to sort of just work with one space here. This is going to be very useful in that we're going to have points and we're going to have to draw lines between them. Oh, more people who join, welcome, right on, just starting. Beautiful, beautiful. So first step, we have Alejo, we're with us in Fate Me. How's everybody doing? Hope everything is fine. I'm drinking a cup of coffee here. So if you see me get all jumpy, now you know why. So first step, of course, is the paper, the square piece of paper, and getting both diagonals in. So that means that the paper has to fold in half like this, one way, and the other way as well. So we have 1 and we have 2. Now here's an interesting fact about sort of folding. The way we talk and what happens is sometimes not matching. So when we fold, we can say we divide by half, right? We can say that we divide, the fold is dividing the paper in half. But what it's also doing is multiplying it by 2, half being, 1/2. And so now instead of having just one face, we have now 2 faces. So we're also multiplying. The act of folding also does this multiplication thing. So now if I have these 2 diagonals and I have 1, 2, 3, 4 areas, and what we were going to work with is 12 it means that each of these areas has to be divided into 12s. All right, I mean into thirds, sorry. So if each of these is divided into a third, then we're gonna get 12. All right, so first off, we're gonna need to do this thing where one of these has to be opposite. So one of them is a mountain, and the other line is gonna have to be a valley. So same lines, just one is a valley, and the other is a mountain. Okay? Very important that these two be different. One valley and the other mountain. Okay, so I'm going to show you how to fold the big thing. So we're going to work with the whole square is going to be the tile. Now, if you wanted to sort of tessellate this, you would have to cut this into smaller squares so you can actually tessellate it within a paper of your choice, right? Because what we're going to do now is going to be this one. So the whole square is going to be the tile, right? So you have to make more in order for this to tessellate, because if you were to put this on tracing paper, it would take up all the space. Or we could cut this same square into fourths. And so we could work the tile into each of these fourths, right? So that's also something that we can do. But right now, because of the instructions and how to deconstruct the pattern, we're only going to work with this one. We're going to do the big thing, and then from that, we're going to learn the lesson and then sort of apply it within. And also is going to save us on time. And we're going to take advantage that the bigger the paper, the more I can sort of show you. Okay, we have both diagonals. Now I'm going to fold one of them, and then I'm going to see that because this line is opposite, or rather it's coming in a valley, no matter what I do, that's what's going to come in a valley. If I fold the other one, this one's also going to be a valley, okay? So I fold that valley like this, right? So right now I have access to the whole range of this curve. Yeah? So now here's the trick. It's a little tricky, but you know, I think you can do it. All right, let's see how that goes. I'm going to pinch it. I'm going to pinch this bulb. I'm going to pinch it. And then I'm going to bring this pinch down towards one of these sides. It could be either left or the right, doesn't really matter. What matters is that when I pinch, I'm actually having access to as close as I can get to the bottom of it in the pinch, right? That the fold actually is connecting to that bottom. And that's very important. Another thing that is very important is that when you do it, inside has to be matching to this line, and then the line that falls on here has to also be the same of it. So if you have more on one side like this, for instance, then what you got to do is you got to push it within. And if it's not reaching, or if it's reaching, and then this one's sort of like overshot, like so, where, just to say that, you know, if that's overshot where it's not falling on this fold, then we sort of have to, like, you know, we have to compensate for it. So this is a way of getting thirds by eye, right? So this fold's going to fall there, and this fold's going to fold on it. So I can almost hold these two together. I can just make sure that that's folding on my line here. I'm sorry for all the burn. It's a sunny day out here in Monterrey. Sunny days are here again. So I have to compensate and correct as much as I can in order to get, you know, as good a reference as I can. Of course, there are ways to sort of construct this by an actual approximation, not by an approximation, sorry, by actual geometrical construction. But I find that this method is very satisfactory once you get the hang of it.
Hey man, can you go back a little bit just to see?
Sure. To the last part, to the.
Yeah. I'm at the triangle stage.
At the square? Which stage?
Triangle. I already
Okay,
have
gotcha. Okay. So yeah, I'm gonna do it again so the fold doesn't distract. Here. Also, it's pretty easy to sort of just get there. Let's see here. So the rule for this part is one fold in valley, the other fold in mountain.
Right.
Okay, so I have here a mountain, which means that my other diagonal is going to come in is going to be a valley. So once that one's a valley, then this one is also going to be a valley. And it's going to come in. And so what I do is I take my finger inside of the cave here, this sort of hole, and make sure that I'm sort of hitting there at the bottom so that I have access to that connection point, that bottom point, this point.
Okay.
Okay. So once I have this all selected, you could call this a selection. It's all up for grabs. I pinch it. The pinch is supposed to work as an approximation. It's supposed to work as an estimate. But the idea for the pinch is also to do this curve where it's going to go like 1, 2, like an S.
Right.
And so in this S, it has to be the same for all ways. So when I bring down like this, I make sure that the fold that is falling falls on my, so sort of the one that's coming out falls on the one that's coming in. And we got to make sure that this one lands on this line here, on this line. So these three have to be matching, this one to this one, and this one to this one. These two have to be matching. So we can just sort of, push and course correct and pull and course correct. This is very important that we get as right as we can. It's good that we're sort of at the beginning of it because we can do all the course correcting that we need, and it's fine if it gets a little dirty. So here I'm folding it and I can see that, inside it's a little bit off there. You can see how I'm not exactly at the line. So I'm a little bit off. So that means that this one needs to be a little more within. So I compensate, I push, I give it a little more, and then I take away from the one on the top to get it to match to my line. And then I fold. And then I lift. I can again see that it's missing a little bit more, so I give it more. And I take away from the top. And there. Now these two are matching, and on the inside that's matching as well. So the advantage of this method is that once I get one that's good, once I can sort of tally these and say that, got it. What's nice is that the other one, so I turn it over like this, I just turn it over. And instead of doing it again, all I need to do, well, of course I need to open it up. But all I need to do now is just bring this corner to touch on that leg or that arm.
I did it on the opposite side. Will now I have to repeat all the foldings on the opposite side as you do?
What do you mean opposite side? So like if it's a double color?
No, the flap.
Oh no, you're good. You're good. You're good. You're good. So you're here, aren't you?
Okay.
Yeah.
Yeah.
Yeah. So now you turn it over. Now you got to do it for the other half.
Achha, okay.
Okay. So also, one important thing for this one, if you want to sort of do a quick check for this one, once you have one like this, then what you do also is that now you take this fin, this flap here, and then you can take it to the other side as well. And this is also a great way to check, because if it it will prove that if this one is the same to this one, and then this one is the same to that one, then we can say that these two are also the same. So if this is the same to this, and this is the same to this, these two are the same. So it's a nice little mathematical algebraic thing where if one is equal to the other, then that one's equal to the one it's equal to. And so we turned a half into thirds. 1, 2, 3. 1, 2, 3. On both sides. So if each, well, since it's both sides, it would be 6, right? So 2 times 6, that's 12. So this is also the way in which I construct a nonagon, a 9-sided polygon. But instead of using a square as a base, I use a triangle as a base. So instead of going 4 times 3, I'm going 3 times 3. So that's how I get a 9. Fifths, you could do it like this as well, but just thinking about going like 1s, 2s, 3s is I think would be a little more difficult to get that pinch going. And there are some articles that you can find by Robert Lang on quintessecting an angle. So that's splitting an angle into fifths using origami. But like Robert Lang is way more of a construction kind of guy. He's not that big on eye constructions. At least not for like the articles, right? You're not going to write a scientific paper on doing something by eye. If you're going to write a scientific paper, you have to be able to sort of prove your method. But for right now, because we're sort of doing a construction with our hands and the result is what matters, not the sort of whether it is or isn't. Appearances are enough. So, I always tell the story, but there was this kid. I didn't even meet the kid. I used to be more like within the origami community here in Monterrey. And there was this kid they told me about who always like exclaimed that, "I am an origamist, I demand to be perfect." That was like his thing. That was like his calling card. And I always, so not resented, but I wish I could have met him so I could have told him that it's not about being perfect. The intention is what counts. So what I'm doing now is I'm taking all these lines, which I have here, and I'm folding them all to be in the same state. All in the same state. So by state, I'm talking whether it's a mountain or a valley. Now, there are no wrong answers, so there's no, like, should I do it to one way or to the other way? It doesn't really matter, as long as they're all the same. But if you wanted to sort of null this, you could null this if you fold it both ways. So if I fold here all mountains, and I wanted to make it flat, I could fold all these mountains then now to be sort of the opposite way. So I turn my paper over, now they're all valleys, and then I'm going to turn the mountains on this side. And this is a very interesting thing because if you wanted to sort of cancel out your folding, this is the way you do it, by turning all the folds both ways. So once all the folds are sort of established as being either one or the other, what you do pretty much is just nullify it, which I think is interesting. As you can see now, it's a little more flat. You see? So before I did it both ways, it was sort of like bulging a little bit. But because I folded it both ways, now the paper can actually be flat. So that's a way to get your folds to be flat, just in case you wanted to know that. Okay, established first step. We got 12 points going around. So all these 12, so it's going to be 1, 2, 3, 4. Well, yeah, there's a point here that we're not sort of getting right now. We should get it, but let's see here. It's, how was it? It was going to be like here and here. Okay, so we're not going to construct it just yet. First off, we're going to sort of avoid any unnecessary lines. We're going to just try to keep it bare minimum. So we're going to do something called a 12-3. Okay. So if you're not familiar with your Schlafly symbols, it kind of goes like this. A Schlafly symbol is written with a bracket, and then you write your n-sided polygon, and then a dash, and which star it is. So that's how you write this star we're going to work with. So this form can be expressed as, bracket n / and then we're going to write a number k. And so k has to be more than 1, and k has to be less than half of n. So that means that if we have n 12, k has to be more than 1, but less than 6, because 6 is half of 12. And so what that means is that if we have 12 points around the center, I'm going to write first, this is how I sort of write them. I write 6 and then what's going to be 1 in between each of these. So I have 12 points, it's a little oval shape, but then it goes 0, 1, 2, 3, and then I draw a line. And then now this is my new 0, this is my new origin. So it would be 0, 1, 2, and 3. 0, 1, 2, and 3. 0, 1, 2, and 3. And as you can see, this will close into a square. So what if we divided 12 by 3? That's actually, we can actually divide that, right? It's going to be equal to 4. So a Schlafly symbol like this, where k and n are divisible and have a common factor, we can actually write the result of the division within, and this sort of the divisor, the, what's the name of it? The numerator, I think it is, outside. So 3, 4. So that means that we have 3 squares. So if I repeat this process, but so it would close, and this would be my new 0, 1, 2, and 3, right? 0, 1, 2, and 3, 0, 1, 2, and 3, 0, 1, 2, and 3. I'm going to do this process 3 times. It's going to close into 3 squares, right? So 12, 3 is equal to 3, 4. Now we're back to this. 0, 1, 2, some invisible point we don't have, 3. 0, 1, invisible point, 3. 0, 1, invisible point, 3. 0, 1, invisible point, and 0, 1, invisible point. So you can see the character of this fold. Okay, so we're going to do this, of course, twice, and then we're going to get the other one by intersection. So it comes on from that point over there to this point over here in the bottom. Now keep an eye out for any relationship which you can sort of use in your favor. Anything that you can sort of recognize, that's good. So for instance, for me, I'm seeing that this point is falling right on this line. This corner is falling right on that line. And also coming in from this point. Actually, you don't have to do this. What I'm gonna do right now, you don't have to do it. But I'm gonna do it so you guys can sort of see a little bit better. I'm just gonna draw in the radial lines. This is worthless. I'm just gonna draw in these lines so you guys can see a little bit better. Does that make it better? Does it look the same? Nah, it looks the same, whatever. But here's another advantage to this. So because it's gonna be a square, we can just sort of do, now we just match it to that one, see? So this next fold, I'm not even counting, I'm just sort of using my edge and then putting that on the fold. Putting that on the fold. And putting that on the fold. And this by its own right, it's a very interesting shape. At least when we get it. This is by its own right, it's actually a pattern in itself. You should have, maybe you've seen this one before. It would have sort of another one, but of course it would be by rotation, or it could be just a mirror image of this one. So in order to complete this shape, you can actually appreciate there a little bit more. And you know, Pythagorean theorem for this one, I think also is a nice little exercise you can try and do. And then you can also appreciate how this triangle, which we have here, is half an equilateral triangle. It'll be interesting to see if this is equal to this. I don't think it is though. No, it isn't. Okay, so we've done that for that one. Okay, good. So we have one square, now we gotta get the other square. So the one that goes from here to here. Zero, one, invisible, three. Now make sure of two things, well, three things. That it hits this point, that it hits this point, and that the corner of my square hits on that line. Once I have one that's correct, everything else just falls into place. And I'm matching again this edge, making sure that that falls there. Falls here. And one more. Again, this is a very interesting shape, and I recommend breaking it down mathematically. I recommend it. It's a lot of fun, I think. At least through Pythagorean's theorem, we're trying to see, you know, what square is this? What's the square root of this square? What is this in relation to this or in relation to this? Like, what are you gonna? How would you solve this, right? How would you approximate this shape? It's a very beautiful shape, I think. It's a great sort of swastika-looking thing.
Hey man, I got lost in the second square. I'm stage 1.
Oh, but you got it. Okay, good. But you did get a square though. Let me see.
Yeah, right. But I got lost in the second one.
Okay, so second one. Okay, so you unfold.
Right.
And so the one that you've completed, you can sort of discard those points. So let's say that this is the one you got. Let's just say that this is the one you got, okay?
Right.
So when I unfold, I can just move down to the next point and then count from here. 0, invisible, 1, 3. 0, 1, 2, 3. Right. So now my new line is going to hit through there.
Okay.
And once I got one that's correct, the others just fall by consequence. So something that is also important about these shapes is the intersections. So for instance, as you can see here, there's an intersection. Here, there's an intersection. And now in order to get the next line, we need the third square. We're going to be using these intersections. So I'm going to mark them with the pencil while you guys sort of finish up or whatever. Yeah. Now, because of the way that folds work, in that we take from the paper sort of falls on itself, if I mark these points only on one side and then I sort of fold within, I'm not going to see my points anymore. So I'm going to turn my paper over right now, real quick. I'm just going to mark these. I'm not going to stay here very long. I'm just going to mark those intersections I see with the radial. One there, 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 here, and here. Because I want all the star to be in the same state. I don't want one of my star lines to be different from the rest of them. So we have those two intersections, these two squares hitting on those radial lines. On these 2 points where the line is going to be at. Bop, 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 right? So there's my points. I can sort of see them there on the back. Line's going to cut through them. And because it's going to be a square, these lines are also going to match to the edges of the square. 1, 2. And we go to the next one. If I'm going too fast, you stop me anytime. So this, again, we're doing the 12-3 on a square. This is the first star we're going to do. So as also another thing is that as we progress, another intersection is going to pop out, and that's this one. We got a little square here in the corner. And because it's a square, they're going to share the same diagonal. These 2 points. So now I have an actual 12-3. I have my 3 squares. One square there. Another square here. And the other one over there. Okay, so good. Now we have this. Now we got all the points we need for the next step. So next step, we're going to do a nested star. So we talked about this before in other classes. The idea of the nested star is to find an intersection within the star that we've constructed and constructing either a deeper star or the same star. In this case, we're going to go now for the 12-4. So just as much as the 12-3, now we're going to go for the 12-4. But this 12-4, we're going to find it on the highest intersection over here. So I'm going to turn it over because that's, sorry, this is the side of the, yeah, this is the side that's going to be visible to me. So I'm going to go 0, 1, 2, 3, 4. I'm going to go again. 0, 1, 2, 3, 4. And again, 0, 1, 2, 3, 4. It closes. So by the same process of elimination, 12 divided by 4 is 3. So 3 stays within, and we're dividing by 4, so 4 gets out. 4 3s, 4 triangles. Now we're only going to need two of these triangles. So we're going to need the triangles that make up like the hexagram. So it's going to be within the hexagon that we have here. So now I'm going to go this, and then it's going to be pretty much on the line. So this one's going to be on the line for that one, and then this one, and here at the bottom. So I'm going to use another color just so you guys can maybe distinguish this a little better. No, it's the same. Yeah, still the same. So everybody got that 12-4? So now we have the 12-4. Now, because we're going to do 2 stars, so I'm going to do this thing. I'm just going to connect these folds by that sort of process we saw at the beginning. So I have these points. I'm just going to do a line that touches them. So a line's going to go through that point, and a line is going to go through that point all the way across. Now, again, you want to make sure that you go through the intersection. That's very important, that it actually touches the intersection of that line. So another way to guarantee that is that this line is going to fall on itself. You can see the fold is going to be falling on itself. And over here as well, this fold is going to fall on itself. You can see both of my points there. Yeah. Now we go for that one, Just going for the 12-4. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Again, make sure that this line falls on itself. This line over here also falls on itself. Now again, make sure that you're actually going through the intersection. If you're not, you can always just pivot and push the fold a little bit, just tweak it, pop. You squeeze, you push. Then finally another one. These are the easier ones, I feel, because then you can also get these to be matching. See that this falls on itself over here? This one as well. All right, so we're getting there. We're almost done. Alejo says, I gotta go. You too, Alejo. Thank you very much for joining us. And yeah, have a good day, man. Peace be with you. So we're gonna be finalizing these point to point, point to point.
I did something wrong. I don't know. I think I was looking too much into my paper.
Why?
I missed your.
Let's see. Let me see here. Which one do I show?
The one you're showing, Sachi.
Oh no, that was because she was having trouble finding what she did wrong, and so I just showed which points that she was doing so she could see that which ones they should be.
I want you to place the pencils the correct way.
Okay, the correct way. Yeah. So it goes from that top point to this bottom point.
Mm-hmm.
And then here. And here.
Oh,
so it's the,
okay.
Here, okay.
So it's the top intersection, and then we do the other one as well. So as you can see, we're matching at these top intersections here. So you can almost use this as a guide. So you get that top intersection, and then you go from that one, and then, well, the thing is, when you count around the circle, you have to count that point at the intersection. So if we're counting for these are the ones that count. So we go 0, 1, 2, 3, 4. And then we go from here, 0, 1, 2, 3, and 4. So then we can see how these can then do 2 of these triangles. So we only need 2 triangles. We don't need all four of the triangles. We could, and I mean that in a hypothetical, do all 4 of the triangles. I didn't do it because I wanted to be more economical on my lines. Even for this one, I didn't do, as you can see here, I have my hexagon marked. But for the other one, I used the other hexagon, the other triangles. Same points though. So all of these squares have the same 12,3 as a base, but I changed up the 12,4 on, well, at least because we're only going to select 2 of the triangles. So my selection for this one is this top one, but not for here. My selection for this star is going to be over here. And the next one is going to be at the top again. And this one's going to be on my right again, or my left. So it's this change.
Okay?
Let me see. Exactly right, exactly right. Now, what's interesting is that we could also just picture this to be,
Wait.
you know,
Oh,
so it's the same thing. I just rotated it like this. So same thing. We had like that, and then so when we do, so the next sort of unit, now thinking, I'm sort of getting ahead of myself a little bit here. But if we have a unit, we can also picture the unit as being this rotation. So someone says that this one is like this, and the next one would be rotated like this. Okay, so once we have those 6 lines, I'm missing 1 line.
Good that you're missing one line. We can catch up.
Yeah.
Oh, 10 minutes.
So now we're almost done. We're almost done. We're going to do one final nest. And this nest, the next one and final one, is going to be located on the vertices of our inner hexagon. So that's here, 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 and here.
we have just marked the green ones, right?
Yeah, so we only care now about the inner points
Okay.
of the hexagon. Inside of those 6 points, we're going to do another hexagram. So we're going to do what's now a 6-2. So we only take 6 points into account, and we jump 2 points. So it's going to go 0, 1, 2, 0, 1, 2, 0, 1, 2. It closes. So 6 divided by 2, that's 3. So there is a common factor. Therefore, that's what we call a compound star polygon. A compound star polygon is when K and N share a common factor or can be divisible. So this is a compound star polygon. So the one that is not compound for the 12 will be the 12, 5. This is not a compound. It's actually a star polygon. I think that's the only true star, like unicursal star for the 12. The 12, 5. Because 12, 2, 2 can be divided by 12. So that would be 2 6s, so 2 hexagons. 12, 3 divided by 3 gives 4. That's 3 squares. 12 divided by 4, that's 3. So 4 triangles. And then 12 divided by 5 can be divided. So this would be an unicursal star. When they can't be divided, you can draw the whole star without taking your line off of the paper. Whereas when it is compound, you're going to have to be sort of, you finish drawing one of these, and then you sort of have to lift the paper up to go to the next point. So these are the compound, and these are just the stars. So right now we're only working with compound, as you can see. So even the hexagram is compound. It actually is, if you go to the books on symbols and whatnot, they usually refer to the hexagram as the union of male and female. So that's also like the idea of like one triangle is facing one way, the other triangle is facing the other, and they are integrated. So again, we do a 6-2 on here. So also you'll notice that I'm doing the marking of my points on the side that they're mountains. So all my lines have been the same state. They all have been the same state. All my lines are the same state. Also, you may have noticed one other thing. I've just noticed it, but if we completed this intersection here with the other one, we would actually get these little squares. Can you see the little squares here?
Hmm.
So that's something interesting, because then what that would suggest is we could then sort of find the place where there's another square there. How would that be? No, it would be more like this.
I don't know full square.
No,
One
that,
line is missing.
yeah, no, this is a hypothetical. Don't
Yeah,
think
only
about this.
three lines.
Yeah, I get a little bit off topic sometimes. Like, this is curious. It's one of the fun things about these patterns, that you can always sort of dive deeper. So yeah, my point was, there's one side of the pattern that I'm marking, which are the mountain side, and the valley side I'm pretty much leaving bare. So I'm gonna take the time right now to sort of erase everything from my valley side, because this is the side that I'm gonna be drawing the pattern into. Now, I insist, this is just sort of like a big tile. So if we wanted to do an impressive pattern, what we would want is to have either a smaller square, which we can work with, or make a lot of these. So again, so the thing I'm keeping an eye out for is that it goes through those points, and that this line falls on itself, and this line also falls on itself. And it goes through those points. These lines falling on themselves, the more exact we are, the more these lines are actually going to be there in the correct spots. Those points. I can see my triangle up here. I can see I can notice a hexagram, so I can know that it's going to be these 2 points. And there are my green dots. See here, I see that I have some inaccuracy. Why some inaccuracy? Because when I fold it, I can see that this line is not falling on itself. I can see that there's a little deviation here. But it's fine. I mean, it's not perfect, but I can work with it. Even if this is not falling on itself, I still have my points, and my pattern will still work. It's fine. Worst things have happened. Now, this line will not, I repeat, will not fall on this vertex. So this fold will not fall on where this line is touching the edge. So I'll actually go a little bit, it will miss it. It will not land there. So if it lands there, just pivot it or move it a little bit, because that's not where it should be. That's what I call temptation points. And that is when something seems to be, like, hey, that's something. And it turns out it's not, it's a false positive. It looks like it's going to be very symmetrical, and then you look into it and it's not. I mean, not that it's not symmetrical, it's just not exactly on that point. So it's tempting you to fall for it, but we resist temptation. This one actually needed a little more push. Alrighty. So that pretty much does it. These are all the lines we need for our pattern. So our pattern is within these. So I'm going to take out my pen, just so I think that you guys can see a little bit better. And so I'm going to begin to trace this pattern. So everybody ready so far, or should I wait a little bit before I do this?
Yes, I'm done.
All right, good. So I want you to first notice how there's now a hexagon here. That's the same as this one. So first step, we're going to sort of do these crosses. So this cross goes from here to that point where it touches this line here.
Till bottom. Reference point is
Like this hourglass sort of shape. We can also then just do this one where it goes here for there. And this one is actually going to be another full hourglass shape. It's going to go full.
I was just doing this in the morning today, but now again I'm lost.
Okay, so did you get the 6-2 inside of the hexagram?
Yeah, yeah, I'm done with. I'm done. Yeah, I'm
Okay,
done
good.
with all the folding.
Okay, good, good, good. So what now we're going to try and focus on is that there's a central hexagram. So now we're going to trace that hexagram and just mark the outer hexagons. So another way we could think about the hexagram also is to see it as a series of hourglasses, a series of crosses like this.
Oh, I found it.
Cross, 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 cross. But then the point where you stop the cross is where it hits the lines of our first star. See?
I didn't get the time to see your pattern. Otherwise, things would have been simpler for me.
You didn't get the what? Sorry?
I didn't get the time to see the pattern because you sent that little video sort of thing.
You didn't get to see the pattern. Which one?
This you sent it, no? On your.
Oh, do you mean the video I put up in the Instagram?
Huh.
Oh, what do you mean? Oh, right now. Do you have all the lines and the points?
I guess I have all the. I should take another pencil because I can see it. I
Yes.
have all these lines.
Okay, perfect.
Just show
So
me the
now,
pattern.
so the patterns, I usually try to think about them within a narrative structure. I think that helps me to not lose the thread. So I think of certain shapes as characters, if you will. So main character is the center hexagram. So you can start by marking out your main character, which is the central hexagram. So you can then start to see it. So I'm using the paper here as a sort of ruler, where I lift the paper up like this, and then I sort of use the edge as my marking. So I'm not gonna do the cross for this one. I'm just gonna do sort of like the triangle, just so you can see a little bit better of the character I'm talking about. So that's the main character, and now I have to do the outer hexagons, which I have here as well. So the advantage is that these two are the same, these two triangles here. You can see there's a little triangle here, and there's another little triangle over here. So this is the main character of the shape, of the pattern. The center hexagram with its hexagons. And so the top and bottom ones, if we are oriented like this, these extend all the way to the corners. So this line that I have here, and this one extends all the way. And extends all the way. So you can see the crosses. Cross, 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 cross. And so keeping with that tradition or that idea, there's also a cross here. Cross. And here there's a cross. So this cross, I'm stopping it at the point where it hits the diagonal of the square. And now the square is going to be complete. So this line we can just extend completely. And this one will not come in as an extension. Rather, this one just comes in and completes. But now this line is actually going to jump from there to that corner. So we're going to need one more fold here. It's going to go from that point to that point. Just one more fold. It goes from that corner of the square to my top part over here. So this one's supposed to look like half an equilateral triangle. And so this one is supposed to look like this. I don't know what to call this shape. It's like a shield almost, right? So again, that point and that point. Last one. Everybody good so far? Everybody got their lines and their points?
Good.
Yep.
Good, good. Now just a little square. So that pretty much does it. I mean, that's how you construct this tile. Now, if you wanted to tessellate it, instead of just sort of like the same shapes or just moving to the right of it and connecting, that's not how this goes. Even though it does connect and does do this shape, this line, this pattern actually has a little rotation here. It connects like so. So this, we get like this kite shape over here. This one completes into this sort of very forward, like a manta ray almost. And we get these squares at the bottom and top, these two. Sort of will complete a square eventually as we move more, into the pattern. So what I would suggest for this to continue, there's two things that you can do. Either you take like the big step, and I talking like it's going to be a little more difficult to keep it all in the same piece of paper and apply a center of 12 to here, a center of 12 to there. So it can get difficult because, you have to be able to keep this center and these centers and sort of not lose your thread. It took me a while actually for this one. It took me a little bit. I had to employ a lot of the mirror tricks we've seen before. in order to get it, but I did apply also the cross section of these two diagonals, just as we did for the full paper. So I didn't do for the full, like at the center of the 12. Rather, I got the center of the square and then did a center of 12 here, right? And here and all these four. So and that's one thing you could do. And then I'm talking that this is going to be a little bit more difficult to keep it all sort of working together and not lose the thread. It's easier if you did fold it into fourths like this and you cut it. And I mean that you cut a little bit of a square here, you know, get this square out of there. And with the little square, you apply what we just did to it. You do this to a little square. And then you repeat the process for all four of these little squares. And then, you know, you can sort of just do that sort of putting them side by side one way. Another way would be to cut them. And that would, you know, just make a stencil out of it. So there's a bunch of things that you could do. And that's also like where you know, I teach you how to make the pattern. And then the next step is like, what do you do with it, right? And more than have fun. I think that this is a very meditative sort of experience. And then also to appreciate how this has like a sort of movement. I think that's very beautiful. So yeah. So what we did the basic. We did the tile. We did one of these. Now we saw also how these can connect to each other. We see how they're connected by a rotational symmetry. And we see how it's inside of a 12. We see the concept of nested stars being used for slang patterns. And we also get to appreciate how there's this sort of internal weave, which is not obvious. But once you break it down, then you can start to wonder, like, what if there's another point that I can use? Or what if I complete the system of stars and go even deeper? Right? Could I get more detail to my pattern? Could I decorate it differently? And then sort of apply the same sort of rules. And then, you know, it's sort of the questions that you get to sort of ponder on. So yeah, the more you make, the better it's going to look. I only have two here, so it's not that, you know, it also takes a lot of my camera work here. But that's also why I suggest to make them smaller so that you get to appreciate them more within a single frame. Okay, so we're going to move on from the slang pattern part of the session into the tessellation corrugation part of the session. So this is what I'm going to show you now. So this is not difficult per se, but it is interesting to see how sort of like these units, like these shapes, these crosses which I've drawn in there, are everything that you need to sort of do on the pattern. And then it becomes a matter of sort of tracing these shapes and then getting to activate the thing. So I'm gonna, again, show you just a little bit, just show you how you can construct the basic of it. I'm gonna leave up to you to sort of like the expansion on it. So I'm gonna show you the core concept. We only have about, 40 minutes left on the session. So, it should be good, it should be good. You guys ready?
Yeah.
Good, so we need another piece of paper here for us. Yeah, this is a lot of fun. This is very hypnotic. Like once you get like the lines in, it's just very, very hypnotic. And also there's a lot of suggestive sort of possibilities, a lot of possible venues that we could take. So I'm going to clean out my desk a little bit here. All right, good. So I don't know if you noticed, but we were using equilateral triangles. So we need to construct an equilateral triangle base. So it could be an A4, it could be a letter size, doesn't matter. What we do need is a rectangular piece of paper in order to get the bigger grid. So we start by folding this piece of paper in half. The short side of the rectangle is the one that's divided. It's the long sides that get to be together. And by that, I mean that it is the long edge, which matches to itself, and it is the short edge, which is divided in half. Again, divided in half multiplies by 2. Now we have 2 bits. So now we're simply going to take this corner and we're going to put it on the line. And this is what I call a slider. So I'm putting that point on the line and then I'm going to slide it, that corner, sliding on the line, that point, sliding on the line until I hit my corner over here. So there's only going to be one point, and I mean there's only going to be one moment on this slide where this connection is gonna check. This connection is gonna work out for us. And that point is the one I'm gonna fold. So that moment of the slide is the one I care about. So corner on the line, fold coming out from the other corner. Now, this very basic principle, this very basic rule, or this relationship is worth diving into. We're not gonna dive too deep into it, but it is something that's very interesting and worth your time. So simply we just unfold this now. We now have that fold. And now we're gonna take everything that's left over.
Yeah. We can't hear you. I can't hear you. Hello? Are you speaking?
Oh, sorry, yeah,
When
no, it got muted, sorry.
So please repeat whatever you were saying.
Yeah, sorry.
Just full.
So yeah, we're gonna take the remainder after that point, the remainder after that point. I'm gonna put that remainder onto the fold itself. Okay, so now we have that point that connects up to there. And we're gonna take away this little bit we have off. If you have an A4 paper, this should be bigger. As you can see, I'm doing a line that goes from that point over to where that touches on the line we did, the slider sort of thing. I'm also using this as a sort of a limit. I call that sort of like the edge of space almost. The idea being that if you have a fold done, it's easier to see where that point is hitting the edge. And so I lift it up from that point and make sure that when I descend, this edge falls on the edge. That way I'm guaranteeing a perpendicular, and I'm also gonna see that this line is gonna fall on itself right here. This is because this line and this line are parallel. So you see a set of parallel lines. This line is parallel to this, and this one will be to that. So if I unfold completely, now I have a rectangle which has an equilateral triangle fitting within. And now we fold this away. So this little bit, you know, it could be bigger on your A4, but we're gonna cut it away. We don't need this bit. All we need really is this rectangle where we have the equilateral triangle within. Okay, good. Everybody up to here? Everybody good?
Yes.
All right, good. So for the process of the design we're going to try to apply and the idea, we're going to need a grid. So we're going to need as many as we possibly can get into it. So for now, I'm going to just show you sort of the basic of it, so the intention of it. Therefore, we're not going to fold it too much, but we are going to need some degree of division. So we're going to start with a basic sort of idea of just putting it on the other side. So because now it's a rectangle, these relationships are going to be more obvious to us. And by that I mean, notice how this fold we have has an edge coming down, or not an edge, a vertex of the rectangle coming down to the line, right? So we could apply the same thing to the others, the other two, where the vertex simply comes down to the line, and because of the symmetry of the rectangle, that fold will hit exactly on the corner. So we do one, and then I can do the other. And because of where it's landing, we're going to see that actually there's an intersection there, which we can also use as a sort of what I call a landing site. It is a point which sort of welcomes that integration. So now we're getting to see that we're sort of multiplying the lines of our triangle. There's more lines to it. All right, so we're going to keep this going. So we're going to do a series of parallel lines. So in order for this to work properly or better, we're going to have to see there's going to be 3 lines to this set. 1, 2, and 3. And now there's another 3 which are going to go between them. So 1, 2, and 3. Those 3 we're going to do on the other side. Although it's not strictly necessary. So, you know, this is just take it with a grain of salt what I'm going to do next. But it is more interesting to see sort of the reactions that we get from the paper. So I'm going to show it to you that way. In where we have these 3 in one state, and the next 3 are going to be in the other. So that's why I turn my paper over. Right? I'm going to have it be on my mountain side. And now I'm going to do a fold that goes between these. So between here, between there, and between these. So first off, I'm going to see that this is simply going to fold in half like so. So what I'm going to do, if you can appreciate sort of the nuance, is put 3 lines that go through these triangles. So now I have 1 line, and now I got to put the other line in. So if you picture it another way, you can see that it's 1, 2, and 3. You can see there's a triangle here. So I can just take this corner and just put it there. You can see I'm pretty much just repeating the process there. And now finally 1 line that goes between these. So there are plenty of suggestions now in that we see more triangles come out at us. We see, for instance, that here we could do another line that goes from there to there, right? In order to complete these triangles which we have here. Right? I have this triangle, but I don't have this one on the bottom, so I'm pretty much just going to go for it. So very nice relationship where the corner is meeting up on that point. So again, the process we're doing is to get as many equilateral triangles as we can in order to get a proper or a more satisfying combination of effects. And the way we look at it, of course, is that we have these triangles, which have now been divided in half. So I'm going to turn my paper over, and I'm going to use these points now as my reference. So now I can actually do or find where there's going to be another triangle within. So for instance, it's going to be there. So I'm putting my vertex on this intersection here. And you can see how it's cutting this triangle in half, hitting exactly on these lines. So we can also appreciate how this one would simply be a half as well. And now one more over here. Let's see how that line is going to match to there. This line is going to match. And if I see my intersections, this point is going to line to that point. I can also turn my paper over. Yep.
Are we repeating the smaller triangles on all corners?
Yes, pretty much. So you know how I said that the intention is what counts? That's pretty much what's happening. So our intention is just to get as many triangles as we can right now. So we're just going deeper and deeper and deeper. And this process of going deeper and deeper relates somehow to how we do a square grid, where we get more and more squares as we divide in half. It's similar, but a little different. So yeah, we're gonna sort of repeat this process for instance, I can say that I solved this triangle. I can say that I solved this triangle because this triangle is already divided within. And now I go to my next triangle, and now I have to solve for this one where I'm missing one of these lines. So I can finish this solve. So this one is this line coming in at that point, this line falling on itself. And if I turn it over, same thing where that one's going to fall there.
What am I doing?
This in half as well.
Some of my lines are mountains, some are valley. I don't know what am I doing.
Oh, it's fine. Yeah, it's something that I like to do sometimes, where I sort of try to keep these different, so 3 sets of lines in one way and 3 sets of lines in another. So here's my 3 for this side. So I'm gonna put 3 pencils to show which 3 I mean. So there's one set of my valleys, and as you can see, like these are all parallel now. So for this green one, this one's parallel. I'm missing one line over here. I'm gonna put it up right now. There's the other one, and we can see it's parallel, parallel, and finally we have these ones. Parallel, 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 parallel. Missing one over there as well. I mean, this is something I'd like to do in order to sort of make the most of the relationships, because these intersections, as you can see, the paper sort of wants to even interact with itself right now. So that's also a lot of the fun of what makes it interesting, that we can sort of play with these. Now the cost, I say cost in that these units have a sort of a price to pay. They go inside of a certain number of triangles. So for this shape, each of these has a cost of 6 triangles. There's a line that goes for 2 triangles there, 2, 2. So each of these lines, 6, 6, 6 lines. So as it stands here, we don't have yet enough to cover that cost. Right? I mean, if we went through it like 1, 2, 3, 4. So not yet. We need one more step at least in order to satisfy that cost. So, you know, we could take also advantage of the fact that we're pretty much just folding in half, right? I mean, as you can see, we started out with this full thing, and then we did half of that. So the next line is pretty much just going to be, you know, on the half of this. So because that was the way it works, then we just sort of match to there and get the half of this.
Other side also?
Yes, other side also, and then this one can also be cut in half like this. So we're pretty much just using the information of the grid. Thank you, Rupsa. Hope you enjoyed it. And yeah, we'll see you next time. Thank you very much. Take care and have a good night. So now, in the same sense, we're going to have to put this line to this line. You know, we're just pretty much just dividing in half and half and half.
Okay, we have to divide these diagonals also.
Yes. Oh. Yeah, well, it doesn't really matter. Really, it doesn't really matter which state it's in. I mean, I like to keep certain consistency on it, but I mean, to tell you the truth, we can always change the state it's in. So if it's a mountain, we can always change that into a valley. If it's a valley, we can always change that into a mountain. So it's inconsequential, but it is a sort of discipline that I try to keep. But it's not something that is really that much important. Just not because it doesn't affect the pattern, but because we can always interchange to the other. So if it's the wrong one, we can always just correct it. So. Excuse me?
Nothing.
Oh, sorry. A little bit over.
Oh. Wrong line.
One more for me. So I think that this grid should cover the cost in a minimal way, but it'll cover it. Because now we have more than 6, you know, going across. We can actually count these. 1, 2, 3. Again, this is bare minimum. So I think that it's worthwhile to sort of consider the possibility of expanding almost. I mean, in a way, we could also appreciate how if it's going for 3, we can always divide the cost by 1. I mean, we can always sort of picture things to be factors of it. But let me see here. I mean, because it's a diagonal of this rhombus, I mean, it's hard for me to sort of appreciate how that would be in a bigger triangle and still work in the effect that we need it to, but we're gonna ignore that. Okay, so everybody got this grid so far?
No.
Okay,
Nothing.
okay. I'll wait.
because I think I've done some other halves. I'm getting wrong.
Yeah, actually, because it's half, I mean, maybe I showed you this sort of convoluted way of doing about it, but there is an easy way to just fold for half in that you can just simply take two lines, which are going to be like, for instance,
That's
these two.
better. That's better. Yeah.
Yeah, and then just match
That's
line to line like that. Just sort of like the accordion way, you know, just like up, half and half, and half and half and half, and off you go.
That's how we do for tessellations. I don't know why didn't I think of it.
Yeah. I mean, I like to do it this way only because for the process that's next, we are going to need all the lines of whichever grid we choose to be the same state. But as I said, you know, we can always change the state. It's not something that we need to do from the get-go. As long as we
Because
can.
this is so much easier.
Yeah, definitely. Just think about it in halves. Yeah. I mean, it's very interesting how this rectangle can still allow for just half divisions, and you get like this grid of equilateral triangles. So I think that's very beautiful.
These are rectangles. I'm
We
getting
get a
rectangles.
well, yeah, we get this big rectangle which we're using, but inside of it, of course, it's still.
My grid is rectangle. No.
Well, this rectangle is.
No, it's incomplete. It's incomplete.
It has a height of √3 and a length of 2. So 2 to √3. That's the proportion of this rectangle. 2 to √3. So we could keep dividing this thing and get a much more resolute grid. But I think for the purpose of time, we have about 20 minutes left, 30 minutes left.
Okay, you finish it. I will do it from the recording.
Yeah, I will show you the pattern, sort of how you draw it, or how you can think about it, and then the idea is that you can sort of take it deeper, because it's only when you get more that you can actually appreciate it for what it is. Okay, so you guys ready for this thing, the solution?
Yeah.
Okay, so here's how we can approach this problem. So we're going to see these sort of rum shapes happen, these little rums. So it's almost like it's these two triangles we have here. So it's going to go from one point to another. And it's going to be like 1, 2, and 3. And then we're going to go, so this point is going to be an intersection and it's going to cut down now. 1, 2, and 3. A total of 6 triangles, but 3 rums. And we got to go for the cut. So all the rest of the triangles that we're going to put in are going to be the same triangles, just sort of be a reorientation of them. So next one is going to be, for instance, here, right beside it. So it's going to go, has to be the same. So if we're going to choose this, these are also going to go. So 1, 2, this one goes all the way across. This one comes down. This one comes down like this. So next one is going to be these two. So it's going to come from here. So one all the way. It's going to cut through there. So we're also sort of rotating around a triangle here. And as you can see, these lines are coming in the same way as these. So, I mean, the idea being that this is sort of like the same unit just sort of moved or translated along the page. So for instance, here now, it's gonna go now. Why am I choosing this direction rather than this one? And that's because we're gonna mind this triangle. So it needs to respect the sort of like rotation of it going around. So one goes to here, other one goes there, other one goes there. So you can see this tri movement. And whatever line comes out, it's got to be the same as everything else. So that's why we sort of can anticipate it. So we can also notice how it's always going to be, well, at least for mine, I chose the left-hand triangle at the point. So this is also the left. So this one's going to be my left. It's going to be this one. So if it's coming in on there, this one's going to come in through there. So it's this top. It's going to go down there. And then here, it's going to go down there. And because it's this, it's going to go down there. So I pretty much covered the page with the pattern we're going to do inside of the grid. Now, these lines of this unit, not these though, these are going to be not the same state. I mean, the triangles are going to be valleys if these things are going to be mountains. So I'm just going to erase triangles so we don't create any confusion regarding the states. So now, what we have to do is we need to fold these lines that we've drawn in into mountains. So this line, I need a mountain that goes from that line. So I'm going to pick it up. I'm going to draw in a mountain on that line. And I only care about that line too, only that line. And so what I do for these is sort of like, you can see how it's my index and thumb, middle finger underneath the paper, middle finger underneath the paper. And I do this thing where I grab it and pull it. Grab it and pull it, and then that way I can sort of draw this imaginary line. Once I have that sort of like extension, I can then just sort of squeeze it. And then again, forefinger thumb, extend. And I do that for all the lines. Now again, I think this is the bare minimum of the pattern being satisfied. What's interesting though is that we can also, instead of using this little triangle, we could always use a bigger triangle. We could have done this huge triangle over here and sort of apply the same sort of units, these little like triangular cross sections here, but with a little more sort of space between them. And that would result in something different. Now, I'm realizing somewhat that I made a mistake, and my mistake is that the lines of the triangular grid are in mountains, and I'm folding these unit triangles into mountains as well. And for it to work, I need them to be valleys, actually, because I need this to sort of, so I'm going to go ahead and just change my triangular grid into valleys. I mean, it's for sort of a, it's not that tedious. I mean, it's just like a thing of just going whoop, whoop, 1, 2, 1, 2. Just changing these into valleys real quick. Not adding any new folds, just changing these into valleys. Again, do the extension, do the line, extension, do the line. Oh, I got those. Extension, fold, extension, fold, press, separate, that, fold. It's a very powerful move because it'll just give me access to the whole line. Whoop, line. Whoop. Now, of course, this is much more difficult to do if you have a big piece of paper, because sometimes our hands cannot extend fully. If you have a big piece of paper and you can't use your full body, then it's a little bit challenging. And for me personally, it's harder on bigger pieces of paper to do straight lines, because because of the way our hands work, we sort of want to do little bits at a time. But if you do little bits at a time, you sort of can create a displacement. But again, I'm just sort of going on about the limitations or the advantages of having this thing be hand-sized, is that we can actually use our whole range of motion to our advantage. Whereas when we have a piece which extends that motion or that range, it's more difficult. So again, I was just changing these states into valleys in order for these mountains that I'm putting in to interact a little bit better with the environment. Now, also notice how I'm using these points sort of underneath, in this case of the triangle here. And also the coming in here. So that's why we need to use the grid as valleys, because they are the ones that shape around these sort of triangular coming ins. So I think I'm missing these. Yeah, I don't have these. So one of the more difficult things, or rather an interesting insight into these patterns, is that if you don't have the full effect, the full lines in position, it's going to be difficult to sort of get the effect to show, because the folds will naturally sort of find where things aren't satisfied and just use that in order to avoid working. So in a way, paper is very lazy. It will find all the excuses it can to not work. But once you set everything into motion, once you put the necessary lines for this to work, it will have no other choice. But we need to help it. We need to just get it to be effortless, the work.
Looks nice.
So I think that this design also has a lot of potential, in that we could use these same units to sort of separate them more and make a different sort of texture. But also notice the cost, right? The concept of cost, in that this cost 6 across, 6 going one way and 6 the other way. So once we have all these set into position, now we can sort of do this collapse. That's sort of like the difficult part of it. But there's going to be a twist because of the way these are arranged, which I think this is nice though. I like the way this looks. So we could also declare this sort of a finished piece, in that it has a terrain, a motion to it. But we could also take advantage of these twists to do a little something, something. So here's how that looks. As we sort of collapse these into that, they naturally sort of have a way that they're going to go. because of the way these are. So I can push them. Which way is it going to be? Actually, they could go either way, but no. Yeah, mine is going to go to the left more naturally than they are going to be to the right. I mean, the way I figure, you just got to do it and sort of see which way it's going to want to go. So once you do one of these, like these twists, right? Once you do one of them, then the rest are just going to be sort of a consequence of that. I mean, I was satisfied with the terrain, but you know, I just kept playing around with it, and I just, you know, one could solve for it like this, so might as well, right? And also, you know, the origamist in me wants things to be flat because apparently that's like extra points in the origami world. If you can make your design flat, then, you know, more power to you. So on the one side, we have these sort of islands, very regular islands we got. But I like this one on the other side a little bit more because of the way these triangles are sort of displaced. So of course, the more grid we have, the more effect we can put onto it. Now all I'm doing here is pretty much just pressing the thing so that it sort of finally collapses and contracts. And there you go. I think this is a nice pattern. Has a lot of potential for different interpretations and variations on the theme. But it's also a nice way of looking at it in that, you know, you could sort of design a nice effect, a nice little thing that bounces, and then just sort of place that around and make it interact with itself. In a very basic way, we've done this here. But, you know, the more you do it, the more effective it becomes. And also, you can then unfold it like this one is. And then once it's like set up, then it's easier to sort of, you know, just bring it all together. Same rectangle, by the way. This one is the same rectangle as this one. So actually, I'm curious now. Here's a little math question for you. If I do this effect, do you think the area is going to be bigger or smaller than this once it's set up? So is more space being taken away the more pieces I put into it, or less space because it's sort of becoming more effective?
I don't know maths.
So what do you think? Is
See,
this
more collapse, so maybe, but they don't look, I mean.
so if I put this rectangle on top of that one, which rectangle is going to be bigger or have more area?
This one looks bigger, which is in your hand. It looks bigger. I don't know.
Let's see, let's put them on top of each other.
Okay. No, this is bigger.
Wait.
Same. No.
Did I do, no, yeah, this is the same orientation as this. Maybe I did it on the other way though. Interesting. Well, yeah, we're gonna have to look into that. Because I think I may have done this on like one orientation and this on the other. But nah, I mean, no, it's like that. So yeah, we can see how this motif can be carried out. And you know, the more you do it, the more interesting it looks in a way. Has these very interesting shapes that come out of the negative space, which I really like. These, by their own right, these little shapes could actually be part of an Islamic pattern. In a way, I feel that these shapes could be sort of, if we color these and these, we could get like something going, I believe. Yeah, it looks very beautiful. I like it.
That's nice.
So this is what we did today.
I finished my pattern today.
Oh, nice. Yeah, there we go. You see, now we're understanding a little bit more. I'm learning, you're learning.
It was simpler.
Yeah, right. I mean, what's difficult for a lot of these patterns, I mean, for these two, for instance, is to do it now in a way that they sort of get multiplied or like get spread out, right? Taking a very basic thing and then expanding upon it. That's where it gets complicated. But it's interesting, like when you find something that works, that's simple, then sort of trying to find a next step for it. Just get that screenshot for this one. So yeah, I hope you guys, hope you had a good time. Hope you enjoyed the folding.
Yes.
Thank you so much.
Thank you.
Interesting.
No, yeah, thank you guys. And well, next class will be on Friday. I think that was the most voted on the polls. I think the polls are still, the polls are still up. So if you want to do some more voting on the times and whatnot, if you find other times more accommodating, just vote on there. And we'll do it. We'll accommodate for that. And yeah, any other suggestions, just send me a message, comment. And yeah, also if you ever like get curious about any shape that you would rather fold, like, hey, I'm interested in 10-fold, I'm interested in 8-fold, I have this pattern I would like to fold, can you teach me? If you send me suggestions, I'll build on those as well. So if not, I'll just keep finding new patterns and going on them. I'm always looking for new ones, and the idea is, of course, that every class we get to see some new sort of interpretation of an old thing we've done. I don't think we've repeated anything yet, though, but we'll see.
Okay, thank you.
Okay.
Thank you. Signing off, and have a good night.
Bye. Bye.
Thank you. Bye.
Bye.